This is the 1999 Calculus BC FRQ number 1. So the question reads, a particle moves in the xy plane so that its position at any time t, where 0 is less than or equal to t, which is less than or equal to pi, is given by x of t equals t squared over 2 minus the natural log of 1 plus t, and y of t equals 3 times sine of t. For question A, sketch the path of the particle in the xy plane below. Indicate the direction and motion along the path. For question A, we can use the calculator to graph the function. So you want to start by switching the mode of your calculator to parametric instead of function. Then you can go to the y equals and type in the equations. So t squared divided by 2 minus the natural log of 1 plus t would be x, and then y is 3 times sine of t. And then we can graph this, and this is what the graph is going to look like. So if we want a more detailed picture of the graph, we can zoom in. So now we know relatively what the graph is going to look like. So now we just have to copy the graph onto our paper. So we know it begins at 0, 0, and then goes up and crosses the y-axis right below 3, and then curves back down and crosses the x-axis right after 3. Now we need to make sure that we indicate the direction of motion along the path. So to do this, we can find where the equation starts. So if you plug in 0 in x of t, you get 0 out. And then plug in 0 for y of t, you get 0 out as well. So we know that the function begins at 0, 0. So we can just draw arrows showing how it moves along until it crosses with the x-axis. Part B asks us to find when x of t attains its minimum value on the interval of 0 to pi. So to do this, we need to find when x prime of t is equal to 0. So if we take the derivative of x of t, we get that x prime of t equals t minus 1 over 1 plus t. So now we can set that equal to 0. So 0 equals t minus 1 over 1 plus t. So now we can use our calculator to find when x prime of t equals 0. So we can do this by graphing it. So if we go to mode and switch from parametric to function, and then go to y equals, we can plug in x prime of t, and then we can graph it. And find when it equals 0. So it says that it equals 0 when when t equals 6.18. So t equals 6.18. Part B also asks us to find the position of the particle at this time. So to do this, we just have to plug in 0.618 into x of t and y of t. So x of 0.618 equals, and if we plug it in on the calculator, you can do 0.618 squared divided by 2 minus the natural log of 1 plus 0.618. And you get negative 0.290. And you can do the same thing for y of 0.618. And that is 3 times the sine of 0.618, which is 1.738. So your position vector is negative 0.290, 1.738. So part C asks to find what time between 0 and pi the particle is on the x-axis. So the particle on the x-axis is on the x-axis when x of t equals 0. So we can set 0 equal to t squared over 2 minus natural log of 1 plus t. And then you can use the graphing calculator again to solve for this. So if you go to y equals and then plot x of t, then you have x squared divided by 2 minus the natural log of 1 plus x. And you can graph it. And then find when it equals 0. And that is when t equals 1.286. So now the problem asks to find the speed and acceleration vector of the particle at this time. So we know that speed equals the square root of x prime of t squared plus y prime of t squared. So we already have x prime of t from the previous problem. We know that x prime of t equals t minus 1 over 1 plus t. We can find that y prime of t equals 3 cosine of t. So we now know that speed at time 1.286 equals the square root of x prime of 1.286 squared plus y prime of 1.286 squared. And if you plug this into your calculator, you find that the speed is 1.196. So now we have to find the acceleration vector of the particle. So to do this, we need to find the second derivative of x and the second derivative of y. So the second derivative of x equals 1 plus 1 over 1 plus t squared. And the second derivative of y equals negative 3 times sine of t. So to find the acceleration vector, we just need to plug in 1.286 for t. So x of 1.286 equals 1.191, and the second derivative of y at 1.286 is negative 2.879. So your acceleration vector would be 1.191, negative 2.879. So that was the 1999 Calculus AB Free Response Question 1 problem, and you can find similar parametric problems on the 2004 number 1 FRQ, 2006 number 3, 2012 number 2, and then on the link I provided in the description on pages 17, 22, 23, 30, and 36 have problems similar to this one.